Okay, so now looking at example 4 here for creating new power series, we have 1 over x. So we need to recognize that this is the derivative of ln x. So what we can do is we can take our power series for ln x, and we can take, so this is equivalent to, I'm just going to write this down here, the derivative of ln x. Okay, so we know that is 1 over x. So what we're going to do is we're going to take our power series, our elementary series, and we're going to take the derivative of it to find the power series for 1 over x. So if we were to take the derivative of x minus 1, that first term, we would end up with 1. If we took the derivative of this next term, so we're going to drop the power down, so the 2 would go down to the front, and then it would cancel with the 2 on the bottom. So we're going to be left with x minus 1. So we're subtracting x minus 1. And because it does have parentheses, we have to do chain rule, but the derivative of the inside on this one is just 1, so we're multiplying by 1. The next term, 3 would drop down, cancel with the 3 on the bottom, and we'd be left with x minus 1 squared. And then we can continue on down the line. So we could rewrite all of our general terms, and the directions do say to do that, but it's simply just adding in the new input. So we write for our general term, like this general term, like I said before, this x is going to get replaced by the x squared down here. This x is going to get replaced by square root of x. This x is getting replaced by, well, I guess it's not getting replaced by, we're putting x out front, actually. So we're just multiplying by x on this general term down here for example 3. I'm going to get rid of that. Okay, and then this one, we're just taking the derivative of this. And we can write a new general term if we wanted to too, because there is a pattern here. We could write that general term. So I'm going to leave that to you. I can add that on Google Classroom, but I want to see if you get the correct general term. In example 5, we are finding the integral from 1 to t of ln x. So if I want the power series here, the elementary series, we can use this for ln x and take the integral of this. So this is also something that we've done before. So we're going to take the integral of each of these terms. Okay, so if I want the integral of all of these terms, let's go ahead and do the first one. So the integral here, we would raise the power and then divide by the power. And so the first term goes back to here. Okay. Second term would be raise the power to 3 and then divide by the power. So we actually have to put a 3 down here multiplied with a 2. I'm just going to write it out like that. Okay, so minus x minus 1 to the third over 3 times the 2, well, it's 2 factorial, but 2, well, 2, sorry, not factorial. So it would end up being 6. And then the next one, raise the power to 4 divided by the power. So the next one would be x minus 1 to the 4th all over 3 times 4 is 12. And we can continue on down there. And then again, we would show the general term that we're taking the integral, and we could even write a brand new one based off of our new pattern. All right. So I'm going to stop the video here. I'm going to make one more video, and we're going to quickly talk about alternating series and do like 2 or 3 examples.